address first device, then address second device. Okay, this is the address of the first device that is on the I2C bus. This is the address of the second device that is on the I2C bus. When we now want to write on this first one, now we want to write on it, it is 0. We want now to read from it, we convert this place to become 1. And when this particular bit becomes 1, the address will change. What we are now going to have, this place will now become A1. That is the address bit for reading from the first device. When we now want to read from the second device, we change this place to become 1. The address will now be 1 plus 2 becomes 3. The address will now be A3. So with this method now, you can connect up to 4 or 5 I2C device on the same bus. I think I have explained very well. Remember, A0, A1, A2 is the device address bit that is used to select the device that you want to communicate at a particular moment. If you have up to 4 or up to 2 I2C device on the same bus, this address use it to select the one that you want to communicate at the same time. Okay, let's now go to our Pro Tools. Let's make our circuit. What we are now going to look at is what? How to save information on the I2C device and how to read it. We are now going to look at the sample code. We save information, we read it and display it on the LCD. Let's make our circuit. We start making our circuit. We connect our, I choose port 3.6. Port 3.6 to be my SCK, while port 3.7 is my SDA. Then I connect only but one device, so I'm going to grant A1, A2, A0. I'm going to grant it. Okay, because I'm connecting only one device. Then WP, you have to pull it to ground. Then we now have to pull the clock line and the data line to VCC using 10K resistor. We're not going to pull it to VCC using a 10K resistor. Let me select a resistor. Okay, we have the resistor here. Okay, duplicate it. I'm going to pull it to VCC. This is the basic connection when using I2C device. You pull it to VCC. Okay, let me shift. Now I will connect my LCD. I have my 16:2 LCD. I'm going to connect it in 8-bit mode. I start my connection. Okay, I'm done with the data line. Let me now connect the control line ROS to port 3.0, YE to port 3.1. Then the ROW, I have to ground it on it. Okay, then I now want to use a push button. When I press the first button, it will save information. When I press the second one, it will read that same information that I have saved. So I'm going to connect my push button to port 1, the first one to port 1.0, the second one to port 1.1. Then I pull it to ground. I just want to use push button. When I press the first one, it will save the information. When I press the second one, it will read the information and display it on the screen. Okay, let's go to our firmware. Okay, I already have some code here. Let me remove the code and start afresh. Okay, let's start writing the I2C code. But before then, I want to explain to us how to initiate a start condition and how to initiate a stop condition. When you want to initiate a start condition, this is what you do. The SDA terminal, that is the SDA terminal, you make it high, set bit SDA. I'm just trying to show us, when I start showing us the start condition and the stop condition, I will now enter the code in the sample code in fullness. Okay, SDA, you make it high. If it is in C language, that you want to write, you just do SDA equal to 1. You put your semicolon if you are using C, but we are going to use assembly language here. Okay, then clock line, you also set it high momentarily, SCL, you set it high momentarily. Then at the same time, you call no operation. This will make it to delay just a machine cycle. Then you clear SCL and also clear SDL. With this line of code now, you have initiated a start condition. This method, you just set bit SDA terminal, you make it high, then you also make the clock pin high. You wait for a millisecond, then you make SCL low and also SDA low. That is, when SDA is high, you send a high to low pulse. You send a low to high pulse on the clock line, then you make the SDA low. You have initiated the start condition. Now let's look at the stop condition. When you now want to initiate a stop condition, what you now do is what? You clear SDA, then you also set bit, I'm using assembly language, set bit SCL, then you will do what again? You set bit SDA and then you clear bit SCL. With this line of code, you have initiated a stop condition on the I2C. Okay, this is the two things we are going to look at for now, the start condition and the stop condition. Let's now go to the code in fullness. Going to the code in fullness, remember we have our LCD, we have our communication line. So first of all, you write OG 00H, then you initialize the pins that you want to use. After initializing them, that is what we call directive on assembly language. That is replacing the particular pin with a name, so that it will be very easy and user friendly, that whenever you look at that, wherever you see that name or that label, you already know that you are communicating to a particular pin. So our RS terminal that we connected to our RS terminal to port 3.0, we now do equate port 3.0, then our EN equal to port 3.1. Anywhere we see RS in this code now, we are talking to port 3.0. Anywhere we see EN, we are talking to port 3.1. Then our data line, we can make our data line to be port 2. So we now say port equal port 2. Whenever we are talking about port, we are referring to the whole of port 2. Now our serial data line equal to port 3 port 3.7, I think. Yes, that's when we connect our port 3.7. Then our clock equal to port 3.6. So anywhere you see SDA, you are referring to port 3.7. Anywhere you see SCL, you are referring to port 3.6. Okay, now we are going to initialize our push button. The one we used to save, we call it write. Write equal to port 1.0. Then reader, the one we used to read, equal to port 1.1. Okay, we have initialized our ports, the pins that we want to use. We have defined them. Okay, let's now go to the code infoness. We now say start. It's not must that you are going to say start. You can choose to call it any label you want. It's not must, but me, I normally like using start. You can call it whatever thing you want. Then what again? We are going to use some delay. So we want to use internal timer 0 as delay. So we now start by initializing our time mode register. We move to time mode. We move to our time mode data 01. We are using our internal timer 0 as a timer, not as a counter, and we are making use of timer 0. Okay, we call initialize LCD. Along the line, I will show us the sequence on how to initialize LCD. In case if you don't know anything about LCD, I believe you must have known something about LCD, but if you don't know, you can still make your recharge to know how to initialize LCD. Okay, next thing we call initializing our I2C initialize. Initializing I2C, we just make the whole pin, the SDA and SCL pin, high. We're still going to define all this call. We are calling the initialize LCD, initialize I2C, call I2C initialize. We are still going to define them. Then call test 1. This test 1 is the first test I want to display on the screen once I power on the system. Then and I want to display it on the first line. Then the second one will be on second line, that I call now line 2. Then I call the test 2, the second test that I will display. After, I will begin to define these things one after the other. Then I call a delay. This delay will now make those information that I display to at least delay for some seconds, so you can see what we have there before it will go. I call delay. Let me call it delay 3. I will still show us how I define all of them. Then I call clear LCD. I will now clear that information I have there. Then call test. I now call test 3. Now call again line 2 again. Okay, I will now enter the main code. After that, I will show us how I initialize, how I define all those things, all those variables that I call, those labels that I call test 1, call line 2, call test 2, call delay. I will still show us how I define all of them. Okay, let's go to the main code. This initialization happens only once in this code. If it is in C language, we call it setup. Setup code runs only once. It will not run again until you will restart the system or you press reset button before it will run again. Now jump on no bit write to save. Jump on no bit reader to read. Then jump main. This is just our main code. This is where our code will be looping on. Our code will remain here till we shut down the system. This 2 line of code is our main code. We will now go to the subroutines where we define other lines of code that we have been calling on this particular program. Okay, let's now define save. Save, once we jump save, it will come here. Let's define what we want to be there. We now debounce. That is what we call debounce when writing a code using a push button, or maybe reading a sensor that will come high once and go. This debounce, once we press the button, if you don't use this debounce here, if you don't call this debounce here, when we press this button once, it will save up to 1,000,000 times because of the speed of the clocking. So, but we have now used the bounce here. Once our finger is still on this press button, it will not save until we leave it. It will now save. That is what we call the bouncing. Now we call start condition. Then we now do what? Move to accumulator the slave address that we want to communicate to. Like I showed us before, we have only one I2C device. This is the slave address for write A0. That is because the control bit is low. So this is the slave address for save, and that is the address we have here. A0, that is the address we have here. H. Why we put that H is to show that it is in hexadecimal. Now we call send. This send will now send the information to the I2C device. It will now tell the I2C device that what? Off it. Okay. We now send another page, that is the address page, the location we want to save our information on. Lest I forget, there is something that this I2C we are using here, that is a 24C02. Is a 2 kilobit IC. It's a 2 kilobit memory, which means you can store 256 bytes of information on it. It is a 2 kilobit EEPROM memory, which means you can store 256 bytes of information on it. Remember, 1 character is a byte, 2 character is 2 bytes. So you can store 256 bytes of information on this memory. So we start counting from 00H down to 256 bits. So we want to save the information on the first location. That is, we move the location we want to save the information. We want the location to be 00H. That is the first location. That is where we want to save the information. You can choose to save on any location you want, but remember, it will not exceed 256. There's 256 because that is the maximum memory space that you can save on this particular I2C component we are using. Okay, we now send it. We now send, call send. It will now send this location to the I2C, telling it that this is the location the information that I want to save will be. This is the memory location I want you to save the information. Next thing we do, we now move the information that we want to save. We move the information. Let's say we want to save 06. Let 06 be the data that we want to save. We call send. This 06 now will be inside 001 of the memory. This 06 will be inside 00H of the memory. That is the first memory location. That is 00H. The content of 00H is 06. That 6 is now the value we have on this memory location. Then what we now do again, we call a stop condition. Jump main. Okay, that's what we have. Once we press this button, it will save this 06 on this memory location and now come back again. And once you save it, it remains there. It will not leave that particular location until you remove it. Okay, let's now go down again to